Welcome to the Gen AI Daily Briefing for Monday, July 27th, 2026. The biggest ecosystem move today is on AI security. NVIDIA and Microsoft, alongside IBM, SpaceX, and others, have launched what they're calling an OpenAI security alliance focused on shared open-source defense tools. The notable absence is just as interesting as the member list. OpenAI, Google, and Anthropic are not in it. That matters because this is starting to look like a structural split in the market over how frontier model security should be handled. One camp is leaning toward closed-stack safety, internal red teaming, and API-mediated control. The other is arguing that the attack surface is now too broad and too fast-moving for private defenses alone, and that shared tooling for model scanning, agent hardening, prompt injection defense, and runtime observability has to be built in the open. My take is that this is less about ideology than operational reality. Once models are embedded in enterprise workflows, security teams need inspectable components, not just vendor assurances. If this alliance ships practical artifacts rather than position papers, it could become the default toolchain layer for AI SOC workflows. But the politics are obvious. Open security without the largest model labs creates an awkward gap between where the most capable systems live and where communal defenses are being built. Next up, on physical AI, Enigma has raised a very large $70 million seed round to make robot control feel more like adjusting a high-level parameter than hand-authoring brittle behaviors. The financing itself is a signal. Investors are clearly rewarding teams that sit above foundation models and below task-specific robotics integration, because that middle layer is still painfully immature. If Enigma's pitch works, the product is not another robot brain in the abstract. It's an abstraction layer for controllability, something that lets operators specify intent and constraints in a way robots can reliably execute across embodiments. That's important because one of the dirty secrets in robotics right now is that perception and policy demos have improved faster than deployment ergonomics. The hard part in production is not getting one impressive run. It's tuning behavior safely and repeatably under changing conditions. A company that can turn robot behavior adjustment into something closer to a controls UI than an ML research project has a real shot at becoming infrastructure rather than an app. Related to that, NVIDIA's Cosmos-H-Dreams work for surgical robotics is worth flagging. This is about real-time generative simulation for a domain where data is scarce, failure is expensive, and offline validation quality matters far more than flashy demos. The reason this matters technically is that physical AI has been constrained by the data loop. You can't just scrape the web for surgical edge cases, and even when you have video, what you really need are counterfactuals, perturbations, and structured state variation. Generative simulation is starting to look like the bridge between foundation model pre-training and task-grade robotic reliability. If that bridge holds, simulation stops being just synthetic data generation and becomes a systems layer for training, policy evaluation, and even operator rehearsal. For engineering leaders, the question is whether these simulators are calibrated enough to transfer. In surgical robotics, sim-to-real error is not a benchmark nuisance. It's the whole game. On the research side, one of the more useful agent papers in this batch is the regression tax. The core point is refreshingly grounded. When we add procedural skills or tool use scaffolds to LLM agents, we tend to report average task success improvements and stop there. But across nearly 6,000 runs, the authors show that these added skills also create meaningful regressions, meaning tasks the base agent used to solve now fail after the skill layer is added. This is exactly the kind of result enterprise teams need to internalize. Agent engineering has been too benchmark optimistic. Every new planner, memory module, or skill library adds state, policy, routing, and failure modes. If your eval only measures uplift, you miss the reliability tax. In practice, This argues for release gating on regression budgets, not just aggregate win rates. For platform teams, it also reinforces that the right architecture is often narrower and more composable than the maximalist agent stack. That ties directly to another strong paper, Tracerouter, which argues that model routing for agentic systems should happen at the task level rather than on each individual model call. That sounds subtle, but it's actually a pretty big deployment insight. Current routers usually optimize each inference hop independently for cost or expected quality. But long-horizon agents only reveal whether they succeeded at the workflow level, often after many decisions. So the supervision signal is delayed and entangled. Tracerouter essentially reframes routing as a credit assignment problem over an entire task trajectory. For enterprise deployments, this is the right direction. If you have a procurement agent, a support agent, or a database operations agent, the business outcome depends on the whole chain, not whether call number 3 was routed cheaply. Expect this idea to show up in commercial agent platforms soon, because it maps directly to one of the nastiest cost problems in production: overusing premium models in places that don't matter and underusing them at critical branch points. Staying with agent infrastructure, Causal Forge is an intriguing step toward self-improving research agents that can actually verify their own outputs. The framework is focused on causal inference and uses lean-based formalization to ground the evaluation loop. That may sound niche, but the broader idea matters a lot. One of the major blockers to autonomous research systems is that LLMs are weak judges of their own novelty and correctness. If you close the loop with another model, you often just automate plausible nonsense. Formal methods don't solve everything, but they do narrow the surface area for hallucinated success. In domains where claims can be encoded symbolically, this hybrid pattern, generate with a model, verify with a proof system, or executable semantics, looks increasingly like the durable path forward. I wouldn't read this as automated science is solved. I would read it as one more sign that free-form agent loops are giving way to constrained, checkable ones. Now to models. NVIDIA 4.2-3b is a compact, open model that claims unusually strong agentic performance for its size, including code agent and office agent tasks, while using a loop transformer architecture and a very large 28 trillion token pre-training run. There are 2 reasons this is notable. First, the market still badly wants small models that can do real work, not just chat acceptably. Second, architectural efficiency is back on the table. Loop transformers effectively reuse layers to trade compute and recurrence-like depth against parameter count. If the claims hold up, the implication is not that 3B beats frontier models. It's that the floor for useful local or edge-deployable agents keeps rising. That matters for enterprise privacy, latency, and cost. It also matters geopolitically. Smaller, capable models diffuse faster than giant closed systems. Finally, a worthwhile multimodal paper looks at scaling native multimodal pre-training from scratch. The headline here is that the field is still sorting out whether deep cross-modal integration early in training produces better long-run scaling than the more common late fusion pattern, where a vision or speech encoder gets bolted onto a language model. Native multimodal training is more expensive and more finicky. But if you care about grounded reasoning in physical environments, it may ultimately be the cleaner path. For architects, the practical takeaway is that multimodality is no longer just an interface issue. It's becoming an architectural fork. If you're building for robotics, industrial inspection, field service, or anything where temporal visual context matters, the choice between retrofitted multimodal stacks and native multimodal foundations will shape everything from serving topology to fine-tuning strategy. What to watch over the next few days? First, whether the new Open Security Alliance publishes actual reference tools or just governance language. Second, whether robotics funding continues concentrating around control and simulation layers rather than general-purpose humanoid narratives. And third, whether agent infrastructure research keeps moving toward verifiability, regression accounting, and task-level optimization. That, more than bigger demos, is where the production market is heading. That's your briefing. We'll see you tomorrow.